Hi! This time we have a coding challenge where we should be able to handle a situation where a function fails to do its job. Alright, now let's define a list like this. And then let's define a function like this. And then let's see how we use the function. We notice that once we use an argument that does not match any of the keys in the list, we get an exception and our program crashes. This is definitely not the kind of behavior we would like to see. We would like to check if we could not get a dog returned and continue our program. Now let's see what happens if we use a built-in function called lookup to do the same thing. Now we can see that the function can return a meaningful value. It seems to add just in front of the value. If the key used as an argument is not present in the list, the function will return nothing. This is a typical way for a functional program to report that the operation has failed. We did not find an item corresponding to the key value given as argument. But what are these funny values, just and nothing, that are returned by some functions such as lookup? Well, shortly put, these values have got to do with something called functors. But what are functors in the first place? Well, functor is a mapping between categories. Well, that sounds strange. In case of Haskell program, we are always referring to endofunctors. These are functors that map Haskell functions and types to other Haskell functions and types. Whether Haskell types and functions actually form a category or not is pretty irrelevant here. What is relevant is to realize how important it is to understand the very concept of functor itself. You do not need to thoroughly understand category theory in order to be able to utilize functors while coding. Now let's get introduced to maybe functor. Let's see what it's like. Maybe is a function on types. It needs a type argument such as int or bool in order to become something meaningful. It's important to notice that maybe itself is not a type. It is a means to create a type, such as maybe int or maybe bool or something else. Let's imagine a simple function f, where the input type is a and the output type is b. So if we think about our function f in the context of maybe functor, we end up with something like this. The input type of the function is maybe a and the output type of the function is maybe b. If we now want to represent a mapping between those two functions f and f prime, it would look like this. This represents a function whose input is a function that operates on a values and outputs b values, and output is a function that operates on maybe a values and outputs maybe b values. What we are saying here is that we put a function of type ab in and get a function of type maybe a maybe b out. We can also give this function a name. Let's call it fmap. Now it will look like this. Notice that we can also interpret the function like this. In this interpretation, the function takes a function from a to b and a maybe a and returns a maybe b. Now let's implement our fmap function. If the second argument of the fmap function is nothing, the function will evaluate to nothing. If the second argument happens to be just x, the function will apply f to x and wrap the result in just. So our operations will either end up with nothing or just something. This something is a concrete type. So from now on, if we always operate on values which are wrapped in the context of a maybe functor, we can easily get to know if our operations fail or succeed in the evaluation chain. That's a big lesson learned. Now, let's forget about the theory on functors for a while and see the documentation on the lookup function. If we look at the documentation, we notice that the function returns a value of type maybe b, and that's what we expected. Now that we return a doc in just context, how do we then operate on the string that lives inside that context? Well, you already know that. You can use, yes, fmap function to extract the value and operate on it, just like this. Now this function will simply add an exclamation mark at the end of doc's name, which is first retrieved from the list. Notice that when we use the call the doc function, we don't get into any trouble even though the doc is not found on the list. The operation will simply return nothing and everything works fine. This is because when we apply the exclamation mark adding function to nothing, the result is nothing. So now for our basic examples, we expect only nothing and don't worry about exceptions. So nothing is acceptable, exceptions are not acceptable, and there are no exceptions to this rule. Oh well, I think this was all for now. We are done, and now it's time to take Selma doc out in the wild. Have fun with functors.